Part 1 of Lesson 3.2 is on logarithmic functions. The first objective is to evaluate expressions involving logarithms and just understanding the purpose of logarithms. And then objective 2 is to sketch and analyze graphs of log functions. So we begin by discussing two different forms. We have something called logarithmic form and then also exponential form. And so if you have something in a logarithmic form, such as the log of 16 base 4, this would be equal to 2. Okay? So that's an equation in logarithmic form. It has the same meaning as 4 to the second equals 16. So you can evaluate something in a logarithmic form and also an exponential form. A lot of times the key is changing from one to the other. For instance, if we had 2 to the what equals 8, that would be the same thing as the log of 8 base 2 equals what? Well, the answer is 3, right? Because 2 to the third equals 8. So that's why we'd put in a 3 right here. So changing from log form to exponential form is critical to understanding this lesson. So you're going to be asked to evaluate logarithms. When we do this, they're going to give you a log like the log of 81 base 3. That's how you say it. I always put in an equals x, and so it's in logarithmic form. And now let's change it into exponential. So 3 to the x equals 81. And then from there you should be given numbers that you can figure it out. 3 squared is 9. 3 to the third is 27. 3 to the fourth gives you 81. So your answer is simply 4. Part B, again, put it in log form by putting in an equals x, and then we'd say 5 to the x equals the square root of x. Now, the square root of x is the same thing as 5 to the 1/2. So now that you can see these bases are the same, then you know the exponent is simply 1/2. So when it says evaluate, it's basically just asking you, what is this equal to? Alright, so change it from log form to exponential. 7 to the x equals 1 over 49. Well, 1 over 49 is the same thing as 7 to the negative 2, because 7 squared is 49, so 7 to the negative 2 is 1 over 49. Thus, x equals negative 2. Next one is a simple one. It's in log form. 2 to the x equals 2. Well, obviously 2 to the first equals 2, so our answer is just 1. Here's a little note for you guys. Anytime you have the log of 2 base 2, or the log of 3 base 3, or the log of 4 base 4, anytime those numbers are the same, your answer is always 1. More on evaluating. Here we have 8 to the x equals 512 is how we'd change that into. So since 512 is the same thing as 8 to the third, we know our answer is just 3. Next one, so equals x here. 4 to the x has to equal 4 to the 3.2. Since the bases are the same, the exponents have to equal each other. This answer is simply 3.2. Next one, 2 to the x equals 1 over 32. Well, 1 over 32 is the same thing as 1 over 2 to the 5th. And so we're going to get 2 to the negative 5 is what 1 over 32 equals. Thus, our answer is negative 5. And then part D, 16 to the x equals the square root of 2. All right, now we have to do some changing here. But 16 is the same thing as 2 to the 4th, right? And this is the same thing as 2 to the 1/2. So if we have 2 to the 4x equals 2 to the 1/2, since the bases are the same, we can set the exponents equal to each other. and if you solve, you'd get 1/8. So that's evaluating logarithms. What I've done in each of these is changed them from log form to exponential, and then from there worked out the value. A couple more. Again, change from log form to exponential, so 5 to the x equals 125. 125 is the same thing as 5 to the third, so x would equal 3 in this case. Now the next one here is not in log form, even though you can see a log in the exponent. So this is an exponential form, and we got to change it into log form. So here's how we do that. The base of the problem is 12, so that's the base of the log. What's the exponent needs to go over here on the right, so the log of 4.7 base 12. And then what's on the right hand side, x, has to go inside this log. So if you take a look at what we have, we got the log of x base 12 equals the log of 4.7 base 12. Since the bases are the same on both sides for the logs, you can basically just kind of cancel them out like that, and you just get your answer of 4.7. So that one's a little bit different, you guys. We changed it from exponential form into log form, and then we were able to solve for x from there. Another evaluating a log, we'd say 9 to the x equals 81. Obviously 9 squared equals 81, so we get 2 for an answer. 2b here is similar to the last page I showed. This is an exponential form. So the log of x base 3 has to equal the log of 1 base 3. So again, to help you with this, you guys, this whole exponent has to go over here on the right. The x has to go inside this log, and the base has to become the base of your log. So now, since you can see that we've got the log of x base 3 equals the log of 1 base 3, now you can just cancel off these logs because they're the same. X equals 1 is your solution. So we have some basic properties of common logs. Now, what do I mean when I say common logs? Common logs are logs that have base 10. So if you see the log of anything, the log of 15, and there's no base written right here, that's assumed to have a 10 there. Okay? So what that means is 10 raised to the what equals 15. Okay? So keep that in mind. That's what a common log is. A common log has a base 10. So this example here, even though you don't see a base, there's a base of 10 right here. And it's just called a common log. So this is in log form. We'd change it into exponential. 10 to the x equals 0.001. Now that 0.001 is 1,000th, right? So it's 1 over 1,000, which is the same thing as 10 to the negative 3. And so now, since the bases are the same, the exponents equal each other, and we get negative 3 for an answer. Part B is similar to one we had in the last couple of slides. This is an exponential form. We got to change it into log form. So we'd say the log of x, base 10, has to equal the log of 5. Now, what you're seeing on the right-hand side of the equation, even though you don't see a base right here, a 10 is assumed to be there. It's a common log. So again, we can just cancel off these logs because they're the same base, and we get x equals 5. Another common log. Here we have the common log of 26. So the base is 10, even though I don't see it, so 10 to the x has to equal 26. Now on this, we're not going to get a nice whole number kind of answer. Obviously, it's going to be bigger than 1, because 10 to the first equals 10. And it's going to be less than 2 because 10 to the second is 100. The answer should be closer to 1 than it is to 2. So we'd have to use our calculator for this. So if you guys type in the log of 26 on your calculator and press enter, you should get a decimal approximation. And that should work out to be 1.4149, and it keeps going. Please do that now to make sure you know how to type that in on your calculator. So that would be the answer. All right, the next one. Try typing that in on your calculator. This is the same thing as 10 to the x equals -5. Now, if you type in the log of -5, you should get an error, right? Why is that? Because it's impossible to take 10, raise it to some number, and have it equal a negative number, like -5. So that's why there's no solution. Anytime you have a negative number like a -5 inside of a log, doesn't matter what the base is, doesn't matter if it's 10 or 7 or 3 or 6, it's going to be no solution. More on common logs. Here we got a common log of 10,000. So 10 to the x equals 10,000. Thus, x equals 4. Let's erase that. Because 10 to the 4th is 10,000. Here we have 10 to the x equals 0.081. And this answer is going to have to be less than 1 because 10 to the 1st is 1. Actually, it's going to be less than 0 because 10 to the 0 is 1. So if you type that in on your calculator, if you type in log of 0.081, you should get a decimal approximation of about -1.091. So if you haven't figured this out, you do have common logs on your calculator, but you don't have the other kinds of logs. Log of 0, try typing that in. If you type in the log of 0, you should get an error. Why is that? 10 to the what equals 0. It's impossible to take 10, raise it to some number, and have it equal 0. That's why there's no solution. And then part D is an exponential form. So to change it into log form, we'd say the log of x base 10 equals the log of 3. Now, the right-hand side of the equation is a common log because there's no base written there, so there's a base 10 here, though, even though you don't see it. Thus, we can cancel our log of base 10 on both sides, and that gives us an answer of 3. So the last thing to talk about is basic properties of natural logs. Natural logs are logs that have a base e. E is approximately equal to 2.718. It's a number that gets used a lot with logarithms. Okay, ln, you see on your calculator, is the natural log. Same rules apply here, so now instead of an log you see an ln. Okay, the base of this is e, even though you don't see it there. So e to the x equals e to the 0.73. Bases are the same, and you get 0.73 for an answer. Here's another log. This one happens to be a natural log as well, so it's a base e, even though you don't see it, the base written there. So e to the x equals -5, and just like with a common log, you can't take the log of a negative number. That's why there's no solution. Next one is in exponential form. So we got to change it to log form. We're going to use natural logs. Natural log of x base e has to equal the natural log of 6, and thus we can cancel the natural logs on both sides because they're both base e, and we get x equals 6. Again, another natural log. Here we have e raised to the x equals 4. Now, to figure this out, you're going to have to use your calculator because you can't get a nice whole number on this. So if you type in the natural log of 4, please do that now. You should get the decimal approximation of about 1.3862. That would be your answer. Last 4 problems. Natural log of 32. You type that in on your calculator to get the answer. And we get a decimal approximation of about 3.47. This is in exponential form, so the natural log of x base e equals the natural log of 4. Cancel off the natural logs and we get x equals 4. I'm running out of time in my video. Your homework tomorrow in class will be a worksheet.